National Electrical Code Section 300.3c addresses the use of bare conductors within raceways. It outlines specific conditions under which uninsulated conductors are permitted. Firstly, bare conductors are allowed when used for grounding or bonding purposes. This is a common application, as the grounding system often utilizes bare copper conductors to provide a low impedance path for fault currents. Secondly, the bare conductors must be adequately protected from physical damage. This protection is inherently provided by the raceway itself, whether it's metallic conduit, non-metallic conduit, or another approved raceway type. The raceway serves as a mechanical barrier, safeguarding the conductor from abrasions, impacts, and other potential sources of damage. Thirdly, the raceway containing the bare conductors must not be accessible to unqualified persons. This requirement aims to prevent accidental contact with the uninsulated conductors, which could pose a shock hazard. Access can be restricted through various means, such as installing the raceway in a secured area, at an elevated height, or behind a locked panel. The intent is to limit exposure to individuals who lack the training and awareness necessary to work safely around electrical equipment. Fourthly, the bare conductors must not be subject to inductive heating or overheating caused by adjacent conductors. This is crucial to prevent the conductors from reaching excessive temperatures, which could degrade the insulation of nearby insulated conductors or even create a fire hazard. Inductive heating occurs when alternating current flows through a conductor, creating a magnetic field that induces current in nearby metallic objects, including other conductors. To mitigate this risk, it's important to properly size the raceway, maintain adequate spacing between conductors, and avoid creating closed loops with the conductors. The National Electrical Code provides guidelines for calculating conductor ampacity and dirting factors to ensure that conductors operate within their safe temperature limits. In addition to these specific conditions, it's important to consider other relevant code requirements such as those pertaining to conductor sizing, overcurrent protection, and grounding electrode systems. Proper grounding and bonding are essential for electrical safety, as they help to minimize the risk of electric shock and fire. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices, such as circuit breakers and fuses, to quickly trip and to energize the circuit. Bonding ensures that all metallic parts of an electrical system are electrically connected, creating an equipotential plane that minimizes voltage differences and reduces the likelihood of shock hazards. When installing bare conductors in raceways, it's crucial to follow all applicable code requirements and industry best practices. This includes using approved materials and equipment, properly supporting the raceway, and making secure connections. It's also important to inspect the installation regularly to ensure that it remains in good condition and that there are no signs of damage or deterioration. If any problems are detected, they should be addressed promptly to prevent potential safety hazards. The use of bare conductors in raceways can be a safe and effective practice when done in accordance with the National Electrical Code. However, it's essential to understand the specific requirements and to take all necessary precautions to protect people and property from electrical hazards. Consulting with a qualified electrical contractor is always recommended when working with electrical systems. They can provide expert guidance and ensure that the installation is safe, compliant, and reliable. Furthermore, the exception of NEC 300.3c focuses on the permissibility of bare conductors under very specific conditions. It's imperative to understand each of these conditions comprehensively. Firstly, the allowance for bare conductors primarily applies when they are utilized for grounding or bonding purposes. This is critical in establishing a safe electrical system where fault currents can be effectively directed back to the source, activating overcurrent protection devices and minimizing potential hazards. Secondly, protection from physical damage is paramount. The raceway itself serves as a protective barrier, shielding the bare conductors from potential abrasions, impacts, or other mechanical stresses that could compromise their integrity. Thirdly, limiting accessibility to unqualified persons is crucial for safety. Ensuring that the raceway is installed in locations not readily accessible to those without proper training and understanding of electrical systems minimizes the risk of accidental contact and potential electrical shock. Fourthly, inductive heating and overheating from adjacent conductors must be carefully considered. Bare conductors, especially when carrying alternating current, can generate heat through inductive effects. Overheating not only degrades the conductor itself, but also poses a risk to the surrounding insulation and components. Therefore, proper spacing, conductor sizing, and raceway selection are essential to mitigate this risk. Understanding these conditions in NEC 300.3c is essential for electrical professionals to ensure compliance and safety in electrical installations. Neglecting any of these aspects can lead to hazardous situations and code violations. When considering the use of bare conductors in raceways, a thorough understanding of the National Electrical Code and adherence to best practices are paramount for ensuring safety and compliance. The electrical system's design, installation, and maintenance must prioritize the safety of individuals and the protection of property.